A video to demonstrate regenerative braking and different options of using same motor as generator and current flow options and just to experiment little bit around. So I'm going to demonstrate you the circuit first. So if you see here, we have total 8 cells. Positive side is here, negative side is here. These are our regular pencil cells, which are 1.5 volt. So total 8 cells in series makes it 12 volt. And there is a switch 1 here, and this is connected to motor plus generator. This is a toy motor generator. This is a toy motor which I took from my son's car, and this has a big wheel, and on the wheel I kept a lot of weight so that it will have inertia and it will hold the motion. Basically, like regenerative braking is used in vehicles, and when we use vehicle use electrical energy to accelerate, but when we want to deaccelerate, it uses vehicle's inertia to store that excess energy where existing motor is converted into generator, and it generates electricity, and that electricity is stored in the battery back. Now this circuit comes here and it goes here. When I run the motor, I switch on the switch 1, and then it takes discharging current from the battery. Then motor runs. It rotates this wheel, and quickly after it starts rotating the wheel, if I disconnect the switch 1, you will see a potential develop between these two terminals, because immediately after, because of the rotary motion of the wheel, it became a generator. And this voltage, of course this voltage may not be equal to 12 volt, because we are not having very high RPM on this wheel. So let's say this voltage is 5 volt or 3 volt. That is why I am trying to use this voltage generated to charge only one battery, which is 1.5 volt, and that I will do by switching on switch number 2, and you will see the difference between when I connect it here, how the load on generator reacts and wheel slows down fast enough. So let's see the experiment. So friends, this is my experimental setup. Here is my toy assembly, which has motor and a little bit gear, and there is a wheel which I connected on my table. And if you see, there are two leads. One is red and one is black. So after that I have used a connector cable, and then that cable is connected to my multimeter. Voltage is currently 0.01 because I haven't connected anything, and this is my battery pack. If you see, currently the red wire is connected to positive terminal, and I have this black plus green wire which will be negative terminal. If you see, I have connected two diodes, and what these diodes are going to do is they are going to control the direction of charging and discharging current. When I am doing discharging, I connect this diode which flows only the charging current. So you see, currently the mechanism is running and it is using the power of battery. And then if I try to short this diode with the other terminal, nothing, because there is no current current flowing in the other direction. So we did not use the current of charging current of the generator. Now if I show you another variation is I run this with the discharging current from the battery, and then I short it with the other diode. And when I do so, it quickly it uses the it uses the generated voltage and it shorts it, and which builds up a current inside the generator, and then generator's motion gets opposed, and that is why it stops. So it is like a braking action. If you see again, it is running. If I leave it like this, it takes at least 4 or 5 seconds to stop completely. But if I just short it, it will stop in just a moment. Also, I want to mention one more thing. If you see, the current open circuit voltage is 7.73, 7.77. Okay, it's increasing. So let's say it is around 8 volt. But when you put on the load, the open circuit voltage of batteries goes down, because there is a load attached and it is causing the battery's voltage to go down. And as strong the power source is, it tries to maintain the voltage, and if power source is not strong, then voltage goes down, and that's how we know that power source died. Now if I show you another voltage, this is the after load voltage, which is only 5.59. and now if now my motor is running, it has built up the inertia like when car starts running. So if I just disconnect switch 1, and which will free our discharging current, then see, still there is some voltage build up, because it acted as a generator for some time. Now I show you. Now I am just going to quickly short it. So if I short it, it just gives us a braking effect. See, that's how it is. Thanks for watching this video.